here again at the Holiday Inn, Brandywine, Delaware, United States of America. That's truly Professor Dr. Dolphy Gilpin on the amazing century matrices. We have 3 centuries here that we have noticed in chemistry. We have the amazing 10 by 12 producing 120 elements. That is 1 century plus 20 elements. That's the amazing 10 by 12 chemistry matrix. And we know we also have a century that Mercury itself has about over 100 isotopes. Mercury has over 100 isotopes. Some others that have had a lot of isotopes would have been silver, about 40 plus. And I think samarium has about 34 isotopes. But let's just go on to now the isotopes. So right now, as derived from the A and Z10 multiplied by 12 matrix. First we have no hydrogen. We have protein, plutonium, and tritium. Helium. Next, isotopes we'll be looking at, we'll skip helium, lithium, beryllium, or we go on to carbon. I have 1, 1, 0. They call this the pen consideration. That is proton, electron, and neutron. Neutron. And when you say P-E-N, you get pen. And pen's configuration due to 1 will be 1, 1, 1, and 1, 1, 2. Okay. So carbon 6, and we'll look at the isotope of carbon, carbon 12. C12, look at C13, and C14. And the relative abundance will be 9.89. 1.1 and ppm. Parts per billion. So we come on now to 7. Yeah, we look at some of the isotopes of nitrogen. This is carbon 12, carbon 13, 14, and for nitrogen we look at abundance would be 99.63, 99.37, and 14, and 15. Next we come on to oxygen. Subatomic number 8. And we have isotopes of O, 16, O, 17, and O, 18. Abundance, this will be percentage here. About 99.97, about point or some extrapolations here. Oxygen 17, oxygen 18. And next, on the list of isotopes here, what you know, oxygen has about from number of isotopes, roughly about from O, from atomic number 11 to about atomic number 28 isotopes. That will be subtracting approximately 17 isotopes. And this one has about 16 isotopes. And carbon has about 15 isotopes. Next we go on to oxygen chlorine, F18. This one has medical application, F18, fluorine 18. Come back to putting some medical application of the words here. Some of them are like oxygen and nitrogen as well-known medical application, but those are the more prominent and natural elements. Oxygen, the one that we breathe in every day, respiration, photosynthesis, and all that. Carbon, nitrogen, and oxygen are the natural constituents of the atmosphere here. 10 would be neon, we're not bothering 10. 11 sodium, probably got some isotope of sodium here. 12 magnesium, 13 aluminum, 14 silicon. We definitely look at some isotope of silicon, 14. And for this we have silicon 28.08 and silicon 29 and silicon 30. Silicon 28.08 that's approximately 92% abundance. Silicon 29 has approximately 4.68% abundance, and silicon 30 has about 3% abundance. Silicon I'm reproducing these numbers from my head, from memory, so that when I take the book, I'll give you some more. I could put on the decimal points for the 92 and that, because when you add up these, it's supposed to come out to 100%, but because I've doing a lot of rounding off and estimation here, it might not come up to 100 when you add up these things. So silicon is 14, atomic number. These are some of we have mentioned about 3 prominent silicon isotopes here, 28, 29, and 30. We'll be looking at some more, and we'll be looking at their medical application. But let's get some more silicon. 15 phosphorus. Looking at phosphorus here. 16 sulfur, 17 chlorine, 18 arsenic, 19 potassium, and 20 calcium. All right. some isotopes, elements, and applications. Silicon.